For number 3, we're looking at determining the area of surface of the function y is equal to 4x plus 3 between x equals 0 and x equals 3 revolved about the x-axis. Now, in the case of the area of surface, again we have the function y is equal to 4x plus 3 as x runs from 0 to 3, and we have dy over dx is equal to 4, and for the square of the derivative, again we have to be at 16. Okay, now for the area of surface generated about the x-axis, okay, x is going to go from a to b, okay, which we will have an application running from 0 to 3, and we have 2 pi times f of x. Again, this is our functional notation from what we otherwise say to be y, and we have times the square root of the sum of 1 and the square of the derivative of concern. In this case we have dy over dx, and now integrating over dx, okay, now we have in substituting, okay, now we have for the area of surface generated about the x-axis, again we're going from x equals 0 to x equals 3, and we have 2 pi times f of x. F of x is going to be 4x plus 3, and we have times the square root of 1 plus 16 dx. Okay, now we have a bit of a crowded expression, and as we look into simplifying, now we have 2 pi times the quantity of 4x plus 3, and we have the sum of the constants to be at 17, so we have square root of 17 dx. And if we look at distributing, okay, we can rewrite what we have in the expression. So we say that for the first term we're going to end up with 8 pi x times the square root of 17 and the next term we have 2 pi times 3 times the square root of 17, which will be 6 pi times the square root of 17 dx. And as we look at integrating, okay, the antiderivatives will be 4 pi x squared times the square root of 17 plus 6 pi x times the square root of 17 as x goes from 0 to 3. And as we substitute 3 for x, okay, it's going to turn out that for the sum we will have 54 pi times the square root of 17, and this will end up in decimal terms at about 699.5 cubic units. And so that will be the resulting area of surface in number 3.